Let's really quickly look at the two other attributes. We looked at the crimes data set as we did in last video. Let's look at two more attributes, which is primary description and location. So the first column would tell us about the nature of crime, and the second column, location, is telling us about where this crime happened. And let's see as to what we could discover through the technique of clustering. So a good way to do that is to quickly create a data frame. And we've already read the file, so quickly create a data frame, rename the columns, and we'll do a preliminary clustering with the size of 3. And then we'll quickly, before we plot the results, we will also see as to whether it's appropriate for us to know whether the number of clusters are optimal or not. So let's do a quick plot. See, and here, for instance, if we randomly select the number of clusters, so let me write this again. We'll take the data frame, and then we'll take the clusters, and then we are plotting it between 1 to 3, and let's see how this looks like. So this is a typical way in which three different aspects of information, because here we have taken three different types of crimes rather than taking all 30 plus different types of crimes. We've taken three different types of crimes, which is namely arson, assault, and battery. And then we are seeing whether we could do a cluster plot to discover any patterns. Now, the problem here is that we don't know how many clusters it should categorize or it should assemble towards, right? And for that, we need to define a function called evaluate. This is a custom function for evaluating the sum squared error. So essentially, when the points are assembling towards a given center, they would do so based on the assumption that they're similar to each other, and depending on the amount or the extent of similarity to each other, they would tend to assemble together, just like people assemble at any given public place of gathering. And then there might be some kind of discord, some kind of difference that may exist, and that difference is broken down into the difference owing to the random variations that is within clusters, within the cluster formation itself, any given cluster that is, and then between individual clusters. So that's how the difference or the sum squared error is broken down into, and then we are trying to see which particular number of clusters is going to minimize the sum squared error, specifically the error that is within clusters, right? So that we know that the cluster formation is optimal, and we can quickly do that, and then we'll run this through, let's say, 10 different combinations, and then we can plot this scatter plot, which plots the given sum squared error within clusters for a given set of for a given choice of number of clusters. We can see that the elbow is at 2. This is called the elbow point, and that's typically a good way to start as to selecting the optimum number of clusters. And then we could look at other variations as well.